So a plant is likely to lodge if it's very top heavy. So we can have an assessment of how much toppling can be generated by the height of the plant and also the weight of its ears. So if we imagine that the plant has begun to lodge and it's at maybe 45 degrees, there'll be some leverage generating around the base, and we can have an estimate of that based upon the height of the plant and its weight and its centre of gravity, and this is what this machine will be given an estimate of. And this value is important because it gives you some idea as to the forces which are generated on the plant, which the plant needs to resist either by its roots and also by its stems to prevent root lodging and stem lodging respectively. So the strength of the stem is also very important, and so how strong the basal regions of the stem are will be critical to resist stem lodging. If the stems aren't strong enough, they could buckle and break, and so having a measurement of the strength of the stem is also a consideration. Okay. So this is the lodging meter. So obviously this would be done in the field, but for demonstration purposes we have a plant here which I've removed the ears from, such that we'd put the lodging arm close to the plant, and then we'd simulate lodging by gradually pushing the plant over. The stems are likely to remain rigid, which transmits the forces into the ground which need to be resisted by the roots, and that gives us a measure of the anchorage force or the anchorage strength, and that number is actually measured on this machine. It's a torque meter, so it's measuring leverage, and in this particular case we call that anchorage strength.